I recently learned that my friend's mum had passed away from cancer. Now this news had genuinely shocked me because she was a middle-aged woman who didn't smoke, didn't drink, and was a vegetarian. She wasn't even overweight. Chances are you're probably watching this video right now and know someone that's had to battle cancer. Cancer has been around for thousands of years, and yet, because of its complexity, we humans have not been able to find a cure. But as we stand on the cusp of a new era of AI advancements, it is worth asking the question, could artificial general intelligence, or AGI for short, hold the key when it comes to curing these types of diseases? Imagine how many millions of lives could be saved if we were able to create an AI that was super intelligent. In this video, we're going to cover the latest cutting-edge work being done by industry leaders in their quest to create AGI and help tackle such problems. But just as important, we'll also explore the impacts of AGI on society. But let's zoom out for a moment. But what do we actually mean when we say artificial general intelligence? Unfortunately, there is no universally agreed definition. And while people interpret AGI differently, most experts believe there isn't actually a true AGI out right now. But to give you a better idea of an AGI system, let's think about it this way. In essence, there are two indicators as to whether a system is in fact AGI. The first one is all about versatility. Imagine a robot that can not only whip up a delicious meal, but could also keep your house neat and tidy. But here's the thing, it doesn't just stop there. If this robot truly was AGI, it wouldn't just transfer its skills from one domain to another, but it could independently learn a new skill, like say gardening, even though it wasn't initially trained for it. Here it mimics the adaptability of human intelligence, which would indicate AGI. The second indicator is all about superintelligence. Could the AI system solve really hard problems that human experts have struggled with? So for example, could our robot find the cure for cancer? Or could it make a scientific breakthrough? If it could do either of those things, for example, it would actually demonstrate it could surpass human intelligence. And whilst models like OpenAI's GPT-4 and Google's Bard are pretty impressive, they're not actually AGI. These large language models, or LLMs for short, are basically like clever parrots.
Can you do a cat? How about a dog? Can you bark?
They respond to our questions by regurgitating text. Eloquently, but still regurgitation. They do so based on patterns that they recognize from their training. So they may sound really knowledgeable, but they don't actually understand their responses. And in order to make a cure or discover a scientific breakthrough, there has to actually be a strong understanding of input, which it currently doesn't have. Plus, these models can't actually learn new things after their training has been completed. Let's say for example you ask one of these models how to fly a plane or even drive a car. They would probably be able to spit out a really accurate response, but they can't actually learn how to fly a plane or physically drive a car. But in contrast, we humans can. There are plenty of human pilots out there that also know how to drive a car. And despite our many shortcomings, we humans are actually really good at picking up a wide range of skills and applying our knowledge from one domain to another. So while the likes of say GPT-4 and self-driving cars are really impressive and actually very valuable, they're still examples of narrow AI, not AGI. This skill of taking knowledge from one domain and applying it to another domain is something we humans naturally do, but AI has really struggled to do this. But that being said, this is starting to change. Let's take a real-world example of DeepMind, a subsidiary of Google. DeepMind is on an exciting journey to crack the code of AGI by combining both neuroscience, or the study of brains, with machine learning. Let's say for example you visit this restaurant and you try their katsu curry for the very first time and absolutely love it. Now the next time you visit the same restaurant and you order a katsu curry again, you'd expect the same level of excellence. This expectation is actually formed in our brains by dopamine neurons, which release more dopamine when we get a reward that's actually better than we initially expected. Interestingly, this mechanism is actually similar to a method in AI called temporal difference reinforcement learning, or TDRL for short. And with this reinforcement learning, the goal is simple: to maximize the reward. TDRL adjusts its predictions based on the differences between expected and actual outcomes, just like the way our brains do with dopamine. And DeepMind's famous AI program AlphaZero relied heavily on TDRL, where it was able to learn new games like chess, shogi and Go from scratch. Now, what was so iconic about AlphaZero was that it was able to learn these new games completely from scratch. It was able to surpass human champions in a space of just a few hours of learning, and it did so without any prior knowledge of these games. Here it used something called self-play, where it learned by playing against itself. Unlike us humans, it could play hundreds and thousands of games in a given day without getting tired. And after all, even the very best in games like chess still make mistakes. So why limit the learning with imperfections? And so by using the likes of self-play alongside TDRL, AlphaZero would actually adjust the values associated with certain moves in a game. Then over time, these expected values would actually be updated based on what actually happened in the game. The next time it was in a position it recognized, it would be able to play the optimal move. Now, whilst this sounds good in terms of reaching AGI, there was an issue. AlphaZero couldn't actually transfer its learnings from one game to another. So essentially it would have to learn from scratch every single time. And so to tackle this, DeepMind used a different approach with their latest efforts. Here with their recent program Xland, DeepMind created a digital training environment with AI agents. Now these AI agents would actually play games with other AI agents. They would basically learn from the game itself and also from other AI agents that were playing the game with them. These were simple games but varied from capture the flag to where they had to move objects to different locations. The main purpose was to encourage the AI agents to learn different skills and different strategies by playing these different types of games. So in a game with say more than 2 players, they would be able to learn concepts like cooperation, something they couldn't do before. And each AI agent is actually made up of a neural network, which essentially is like a digital brain. These neural networks are able to understand complex relationships and thus build a model for the environment. And so when a neural network is trained on a set of data, it looks to identify patterns within it. It can then apply these patterns to new, unseen data. That's how we actually know it's learning. So with all of that said, what were the key findings? DeepMind found that these agents performed really well on completing a new task that it had not seen before, without any additional training. The big takeaway here is that with previous reinforcement learning approaches, the AI agents would have to learn from scratch every single time. But it meant this time that their approach had shown that their AI agents could apply general strategies or principles to new situations. So the likes of AlphaZero through to Xland, there is clear progress of AI starting to become more general. And even though it's not AGI, it evidences that AGI is more of a continuum as opposed to a binary yes or no state. The journey to AGI isn't about finding the perfect machine learning solution. It's about combining a variety of different machine learning techniques and evolving them as we learn more. Both DeepMind and OpenAI are demonstrating progress in this area, with a particular focus on gaming. And you may be wondering, why are these AI companies so focused on gaming? And it's because this approach allows them to build a foundational understanding of AI in terms of what is and isn't possible when it comes to creating AGI. Games have clear rules and objectives, which makes it easier to test AI in these environments which are safe and scalable. It makes more sense to actually understand what machine learning is capable of first, before trying to complicate things and apply it to really difficult real-life scenarios. So AI is starting to show signs of becoming more general. But these AI agents typically rely on reinforcement learning, which requires a huge amount of compute power and energy in the form of GPUs and TPUs. Think about it, the algorithms have to play hundreds and thousands of times before they actually start to learn meaningful strategies. So you could make the case that this is quite an inefficient way of learning. But let's imagine for a moment that we actually do achieve true AGI. And let's say it's capable of learning new skills and is super intelligent. There'll be a whole host of challenges to grapple with. Take a moment to consider how rewards in reinforcement learning are defined. In a real world environment, unlike the virtual world which is pretty safe, if you don't define the goals clearly or they're inaccurate, you could come across what's known as the alignment problem. This is where it looks to achieve goals, even if it is in best interest, that aren't actually aligned with what we want as humans. Say for example, an AGI is tasked with trying to minimize human suffering. It might actually decide to sedate all humans. And say it does this. From an AI's perspective, it's technically done its job and it's a tick, but for us obviously it's a disaster. And if AGI actually reached a level of superintelligence, there is a case where by default we'd become subservient to it. So let's think about it. If it reached a point of superintelligence, there is a chance it could even mislead us for its own benefit. And one thing that doesn't actually get talked about enough are the ripple effects associated with these so-called benefits. Imagine AGI truly does find the cure for cancer. Cancer has claimed 9.6 million lives in 2020, so if we had a cure tomorrow, we could undoubtedly save millions of lives in the future. From a government's perspective, would this be a blessing or a curse? How would countries' healthcare's infrastructure cope? Longer lifespans mean an influx of age-related issues such as arthritis and dementia. Our already strained healthcare systems could actually buckle under this pressure, leading to overworked healthcare professionals and actually a shortage of key facilities. All of this could mean longer waiting times, medical staff burning out, and in turn us actually receiving poorer quality of medical care. Countries that heavily rely on public healthcare systems like where I'm from in the UK might be forced to hike up taxes to support their healthcare systems. But let's even take it a step further. Let's imagine we do have this magic silver bullet AGI which could cure any disease. The result would be a lot more people living, obviously. So if on logic there are more people alive, wouldn't there be more competition for already finite resources? This unsustainable pressure could see increased deforestation, habitat destruction, and even increases in carbon emissions. And if we did unlock Pandora's box of superintelligence, there's a scary risk that it could be hijacked and weaponized. Picture an all-knowing AGI in the hands of, say, an incompetent leader, or even worse, an evil dictator. That's a recipe for war and geopolitical disaster. But it's also worth noting that if we do reach a point of true AGI, essentially the AGI would actually be better than humans in everything, from cooking to writing poetry to mechanical engineering. And it could work on improving itself at a much faster rate than, say, us humans can. And even worse, increases the gap between us humans and the AGI. So the intelligence gap between the humans and the AGI grows wider and wider and wider. And this rapid increase in intelligence is called the singularity, where essentially we're stepping into the unknown where we don't actually know what happens, like entering a black hole. That's why companies like Google's DeepMind and Microsoft's OpenAI are so focused on creating a safe AGI. While it is crucial for us to be aware of the dangers associated with AGI, we should find comfort in the fact that these companies are demonstrating a commitment to AGI safety. One approach is promoting transparency. Now, while these companies aren't actually revealing their proprietary secrets for obvious reasons, they are quite open about what products they are working on. And they do share their research not just in public papers, but also in academic and industry conferences. This openness does actually serve a pivotal purpose. When more people understand how AI systems work, it invites thoughtful feedback, especially from experts, where it can mitigate the risk of AI being harmful, because these types of people are best positioned to scrutinize what work they're doing and question whether it truly aligns with human values. These industry leaders are also collaborating with third-party entities on AI safety, allowing companies like DeepMind and OpenAI to access specialized expertise and resources on this crucial subject. And even if we take a step back and look at it from a cynical financial standpoint only, it's not in these big companies' interest to actually create an evil AGI. So whilst companies like OpenAI, DeepMind and other startups are in a race when it comes to reaching AGI, here finishing the race slowly but safely is way better than finishing the race first but recklessly. And governments worldwide are starting to recognize the need for AI regulation. They're actually starting to work closer with the tech giants. China has released a national AI strategy that includes a number of provisions on AI regulation. The US government is also considering a number of bills to regulate AI. And the European Union or the EU is also developing their own AI Act, designed to ensure that AI systems developed are used safely and ethically. So while I could bore you with the details of these regulations, the key thing to note is while there is still a long way to go in AI regulation, meaningful strides are being taken by all parts of the industry. But in the midst of AI safety and regulation, let's not actually lose sight of the true benefits that can be delivered by AGI, where AGI could transform our lives in ways we can't even fathom. AGI could accelerate scientific research in fields like physics, biology, and even quantum mechanics. Nothing would be beyond our reach. With a super intelligent AGI, every single problem that we humans have long struggled to find a solution for could be solved. Cancer conquered. All of your mundane tasks automated. Think about the tremendous boost in efficiency in your life. We as humans would have more time for the things that we love, which in turn could lead to a more fulfilling life. With AGI, we could explore the farthest reaches of the universe. And who knows, maybe even come across extraterrestrial life. we would essentially be able to understand the true nature of reality. Now the big question when it comes to AGI is, when will it actually be delivered? And unfortunately, the truth is, no one really knows for sure. Could it be 10 years? Could be 50 years. Undoubtedly, techniques that we've talked about to try and reach AGI, such as self-play and reinforcement learning, will see advancements as the years go by. But what we can say with absolute confidence is that there won't just be one pure form of AGI. We might see one type of AGI that's purely software, that could crack the code for, say, diseases. There might also be another type of AGI in, say, a humanoid robot, taking care of our chores and picking up new skills all along the way. The development and use of AGI must be done so responsibly, to ensure we reap the benefits whilst minimizing the dangers. The AGI of the future won't just be about finding cures for diseases like cancer, it will be about tearing down the walls of the unknown. In truth, the future with AGI is beyond our imagination. And that, my friend, is the most exciting thing. Thank you for watching.